Although the two Voyagers are safely on their way, problems continue to arise. Preoccupied with Voyager 1, JPL forgets to send a routine command to Voyager 2. Without the command, the spacecraft assumes its radio receiver has failed and switches over to the backup. But the backup proves tone deaf and can't lock on to the signal. By controlling the frequency of the transmission from Earth, the ground crew tries desperately to re-establish contact.
Data chief has to configure this, but this is actually what we are getting in here.
On Goldstone, I would just like to confirm you have acquisition.
Finally, Voyager responds, but the faulty radio would handicap the spacecraft for the rest of its journey.
We have receivers on signal level -145.
March 1979, Voyager 1 approaches Jupiter. It has been a year and a half since launch. Now, a rendezvous with the giant planet seems destined to become reality. Brad Smith of the University of Arizona was head of the imaging team throughout the mission. Although scientists have observed Jupiter for centuries, Voyager's first glimpse of the planet was full of surprises.
We were surprised by just about everything we saw. When we started our first encounter with Jupiter, we thought we knew the answers, we thought we knew what we would see. One thing after another turned out to be not what we expected. During those hours around closest approach at Jupiter, when the very highest resolution pictures were coming back, we were filled with awe, elated, in some cases worried, concerned in that the complexity was so much greater than we could have imagined. There was a certain feeling while we were so delighted with such a rich harvest of science, a certain amount of almost despair as would we ever be able to interpret, to understand what we were seeing.
Voyager revealed Jupiter's turbulent atmosphere in stunning detail. Bands of clouds swirl around the planet, and the great red spot churns like a mammoth typhoon. First observed in the 1600s, this huge storm system is 3 times larger than Earth. After nearly 4 centuries, it still rages. Jupiter spins on its axis twice as fast as Earth. Wind speeds exceed 300 miles an hour. Opposing jet streams create spirals and eddies that appear and then evaporate. Other storms are trapped in perpetual motion. Imagine a world without continents, only oceans of liquid hydrogen and helium. Above, winds roar endlessly. Storms too violent to comprehend rarely abate. Clouds shimmer and crackle with lightning. Such turbulence had never been envisioned. Jupiter's dynamic atmosphere was a revelation, but the biggest surprise was yet to come. Voyager would visit 4 of Jupiter's moons. Countless collisions with asteroids have obliterated the surface of Callisto. Without geological activity to erase them, each scar is testimony to a long and tortured past. Europa is deceptive. Its terrain appears rugged and cracked. But these features are an illusion. Locked in an ocean of ice, they are actually smooth and flat. Ganymede, the largest moon in the solar system, is also battered. But jumbled blocks of ice, the size of continents, and faults reminiscent of the San Andreas suggest that geological processes were once at work here. But of all Jupiter's moons, none was more startling than Io. Its surface was surprisingly smooth. At first, Brad Smith was concerned.
Io, a satellite which was to be a Rosetta Stone in the outer solar system. It was going to be covered with craters. It was going to tell us the age of the solar system, the activity in the outer part of the solar system, and no craters. As we got closer and closer, still no craters. We realized that something was covering up that surface, and the surface of Io was getting younger and younger as we got closer and closer.
Four days later, the mystery would be solved.
Get it done, we can have a snack later, okay?
Today, in her spare time, Linda Morabito Hyder writes science fiction. But when Voyager encountered Io, Linda was a member of the navigation team. March the 9th, 1979 is a date she'll never forget.
It was a Friday, and it was 4 days after the encounter, closest approach. And I was doing my job in order to determine to a higher accuracy the orbit of Io. So this was after the encounter had taken place and the press conferences were over, and the members of the science team were basically on their way to take a rest and had decided a break was in order, and probably felt that most of the wonders that Voyager showed us had already been encountered. And it was in doing my job, I saw something off the limb of Io that I knew didn't belong. What I saw was a very large object off the edge of Io. Now, this large image, initially one would think it would be a satellite, another satellite that was unintentionally captured by Voyager, but it was much too large to have not been seen before.
Her discovery would make the headlines. It was the first time an active volcano had ever been seen beyond Earth. Captured on the limb of Io, its immense plume rising nearly 200 miles above the surface. Eventually, 8 more active volcanoes would be found. What could cause such an incredible display? Jupiter's massive gravity keeps Io locked in orbit. But as the moon Europa passes, it also pulls on Io. Trapped in a gravitational tug-of-war, its surface bulges and flexes. The constant flexing of Io's surface generates heat, melting the moon's interior. As the heat escapes, it produces what may be the largest volcanic eruptions in the solar system. And then, the final revelation. As Voyager prepared to depart, it took one last picture of Jupiter. There, lit up by the sun, was a ring never seen before. A fitting end to a visit full of surprises.
Move the scan platform.
In August 1980, Voyager began observing Saturn.
All right, there it is.
All right,
Great
yeah.
shot.
Yeah, you can tell.
Pointing's good. You can
Yeah.
actually see that
Yeah,
it's a planet.
you can recognize it, yeah.
Saturn is famous for its beautiful rings, but the first images show little detail. As Voyager closes in, resolution improves. Candy Hansen of the imaging team will enhance the color to make the planet's features clearer. Now the full spectrum of Saturn's beauty begins to emerge.
The first pictures we got were about as good as Earth-based pictures from a good observatory. And then as you get closer and closer, and the planet grows in the picture and gets larger and larger, we started to see more and more detail in the clouds. We started to see more and more belts and zones in Saturn's atmosphere. But the really exciting, dramatic thing were the rings.
New and unexpected rings orbit Saturn like a carousel. Where did they come from? How are they formed? How old are they?
What are planetary rings? Rings are...
Larry Esposito lectures at the University of Colorado.
Around the planet Saturn, these particles form a ring, each in its individual orbit.
A member of the Voyager team and a specialist in the new science of planetary rings, Esposito shares a theory.
Here in this table I have a rock representing the planet Saturn, and around it some pieces of chalk that represent small moons. These were probably formed all at the same time, at the origin of the solar system. And these moons are subject to bombardment by meteorites and asteroids. The meteorites which strike these moons can occasionally break them up. The material in these moons is broken up into smaller pieces, each in orbit around the planet. And as all these particles are moving around, another moon will be smashed. And those particles follow their own orbits around the planet. What happens to these rings? Well, the small material is charged by electrons and is pulled off by the magnetic field of the planet. Some of it is dragged in by the atmosphere and ends up in the planet itself. Eventually, the rings that we're seeing here in 1 million years are gone. But there are still more moons around the planet, and these we continually break up to make new rings.
The notion that rings are the product of violent ongoing collisions is dramatic enough, but more discoveries were in store.
In 1980, as Voyager was approaching Saturn for the first time, I went to a meeting and I saw one of my colleagues with some photographs very close to his chest showing other people. And what he was showing was that there were dark lanes on the rings that looked something like the spokes of a wheel. And I sort of snuck over and got a look too. Of course, everybody knew within a month that this new phenomenon had been discovered by Voyager, that the rings had not only striations in a circular sense, but it had finger-like projections that could be seen. And these radial finger-like projections were called spokes. The spokes turned out to be very tiny particles the same size as the particles in cigarette smoke, about a 10,000th of an inch in size, that had been lifted above the rings. And these tiny particles lifted off the surfaces of other particles were what we saw as spokes in the rings.